Assalamu alaikum. This is solid modeling again, lecture number 8, exercise number 2. In this lecture we talked about how to assemble parts together. This is the second exercise, nutcracker assembly. Again, we have all of the files. Again, I am the designer. I should know all details about the parts and the assembly. What are the offset distances, what are the angles, all of the distances and angles, or all informations should be known, because I am the designer. So I have the parts. By the way, these parts, it's already on the on the internet. I just took one of them to demonstrate how we can assemble them together. At the beginning we have to go to new file, select the assembly. Surely if your parts made using inches, you have to go to English units. If your parts made using millimeters, you have to select metric here. So use the same units used for the parts in the assembly. So I will go to millimeter, and I will go to, as example, standard millimeter IAM, Inventor assembly, user interface or file. As I told you, let me go to the place at the beginning, go to the folder where we saved the files or the parts. These are the parts. Let me view them as a medium icon to show you. So let me start from the base plate. Open the base plate. This is the base plate. Right click OK. Now, as I told you, the base plate, it has 6 degrees of freedom. How to show degrees of freedom? You can go to view, not necessary, just to show you. Click here, degrees of freedom. That means it can move in this direction, that direction, rotate around all of the axes. So this is 6 degrees of freedom. When you add a constraint, you are minimizing the degrees of freedom. It depends on what do you want exactly. Now guys, the base should be fixed in our example here. So I will right click on the base and select, sorry, it's not selected. Click here, right click, and then grounded. Now see, I can't move it in any direction or rotate it around any direction. So it's 0 degree of freedom now. Now guys, I will go to place again. Let me select, as example, the hinge. The hinge, we need just one hinge like this, escape or OK, right click OK. Again, I am the designer. I know where I have to place this part. From my knowledge, guys, I know that this surface should mate with this surface, so that this whole axis mate with this whole axis, and this whole axis mate with this whole axis. So easily we can go to constraint to add a constraint. Surely I will start by mate, select this surface, and mate with this surface. Apply, and then cancel. See, it can move, still move in XY direction, but not in Z direction. To show you that, let me go to bottom, and see, I can't move it in Z direction, but it easily can move in X direction, and also in Y direction. To show you Y direction, let me go to this view. See, it can move in this one, in this direction, but rotation allowed just around Y axis. Let me go back to here. Allowed in around Z axis, sorry, not Y axis. So now, as you see, to see the hole in the bottom, guys, we have to rotate like this, free rotate. This is not actual rotation, just to show you or prepare for the assembly. Constraint, I will use mate, axis to axis, apply, cancel. Just to show you what happened now, guys. See, now we constrain the movement in X and Y direction. So if I will go to this view, I'm trying to move it in Y direction, I can't. I'm trying to move it in X direction, I can't. But still it can rotate around the Z axis only, and this is what I want. And still this part not fully constrained. We have to add more constraint. Again, I have to go to free rotate like this, and then constraint. I will use mate, axis with axis, and that's it. Apply, cancel. Now it's fixed. Next step, guys, we have to go to place. As example, let me place the adjuster base. I know that the adjuster base should be made here, so that this surface mate with this surface, these two holes mate with these two holes. Again, same story, guys. Constrain, made this surface with this surface, apply, then free rotate again, free move if you like it, like this, and then constrain axis. As example, this axis, I want this axis to mate with this axis, apply, and the same time again free rotate this part like this, and finally constrain this axis mate with this axis, like cancel. Now I'm trying to move it in X direction, Y direction, Z direction, not moving, not rotating, fully constrained, 0 degree of freedom. Now, guys, again we have to go to place, and as example select this cylinder. I know that the cylinder, this surface should mate with this surface, and just two holes mate with two holes here. So I will constrain at the beginning, select this surface mate with this surface, apply, cancel, and then we can make free rotate just to prepare it, just to show you what I'm trying to do, like this. Now I want to constrain this hole with this hole, this hole with this hole will be enough. So constrain axis of this hole with axis of this hole, apply, cancel. See, we need just one hole, further hole, more hole. Go to free rotate again. Take care about this one, because it's very important to know which one you want to constrain. I want to constrain this hole. Let me go to move like this. Now I'll see, go to constrain, select this axis, zoom in to see the axis, zoom in here, axis, apply, cancel. Now see, I can't move any one of these parts. Place, let me place the adjuster. I know that the adjuster, this cylindrical shape will go in this hole, so let me free rotate to prepare it like this at the beginning. The easiest way, guys, by the way, let me go to view and hide the degrees of freedom. No need, because I know what I'm doing. So go back to assembly. The easiest way, guys, to insert this one here, to use the insert constraint. So I will use constraint, then I will use insert, opposite, so that I want to insert, so that, as example, this edge or this surface mate with this surface, like this, but with some offset. I have to know how much the offset, say, as example, -2, sorry, it should be, as example, 5, say 10. I should know how exactly the distance. Apply, cancel. See, now it can't move on this direction or that direction. Next, but it can rotate around the x-axis. If you want to constrain this movement, you can add more constraint, but for me, for demonstration, no need. That's enough. Place, let me place the piston itself. I know that the piston should go inside this hole, so that this hole will be from left, not from right. So I'll free rotate the piston like this, just to prepare it. This piston should go and move like this, and it can rotate around the x-axis, so I will constrain just the axis. So axis to axis, and that's it. Apply, cancel, like this. Very good. Now we want to place the handle, as example, the handle. I don't know what's wrong here. I discovered that the handle file updated by another version, so I brought the original one. So I will go to assembly again, place. I will use that handle here, should use the same version. Now the handle, I know that the handle, this surface should mate with this surface, and the hole, lower hole, should mate with this hole. So constrain at the beginning this surface, as example, to this surface, apply, cancel, and also we can constrain this axis, I'm sorry, again, constrain this axis with this axis, apply, cancel, show you how the handle moves like this. No, not this one, sorry, this one, like this, guys. Now we should connect the handle with the piston using the connection. We have two connections, this is one, this is two, exit the first one here, say that again, constrain this surface, mate with this surface, apply. At the same time, this hole will mate with the upper hole like this, just to show you from this view how the handle moves. Let me go back again. Now we'll do the same thing from this side. Again, constrain for the other one, surface to surface, apply. At the same time, axis to axis, apply, cancel. Now this is the handle. Now this one should mate with this one. It's enough to mate. Constrain, mating, I think point to point better, so free rotate this handle like this and constrain, say that I want to constrain axis to axis. There is a problem or conflict, so I will select point to point or edge to edge like this, apply, cancel, and let me take it out like this and go back to the second one. I will do it again. I will delete this mate again. I will go to constrain. I will select this time axis to the point like this. It will be better, no conflict. Let me go back to the other side like this again, same story. I will select mate axis of this hole to be at this point, apply, cancel. Because we have 2 points, one from here, one from here, it will be constrained in the correct way. Now the nutcracker is ready. Just to demonstrate the motion, to be like this. Now the same story, guys. We want to drive the motion, we want to show just a demonstration. Now for the assembly, it's ready, no need to add more constraints. But if you want to show the motion, to drive the motion, we have to use one of the constraints. So let me add as example distance. We can add distance or angle. Let me check distance first, constrain the distance between say this surface and this surface, apply. There is a conflict, no need to use this one, I can't use it. Let me use a flush instead of the mate. Flush, make this surface and this surface to be parallel. Also we have conflict, I can't use it. We can use distance between this surface and this surface, flush again, parallel. So make this surface and this surface parallel with 0 distance at the beginning, apply, cancel, like this. And then we can drive the motion. Now by changing the distance, I'm just showing you alternatives how we can do it. So where is this mate? This is with the piston. Let me go to the piston. This is the piston. Okay, right there, because I opened the piston file, no need. I think this flush, right click, select drive, and say that 50, the opposite one. So make this, I prefer to go back to the distance, original distance, double click, right click, edit, distance offset already 50, say that it's -5, say -50 like this, -60, okay at the beginning. Then go back to the flush, drive the motion. I'm sorry, we have to select from -60, say to 0, like this. It's okay. Go back like this. Again, this is not needed for the assembly, just to show you how we can drive the motion. So let me delete it and show you the original assembly like this, guys. By the way, if you want to, if you notice that there is something wrong in one of the parts and you are in the assembly, can we edit the part? Yes, as example, let me select this one. Double click on this one. Now we are inside the file called adjuster. So you can go to revision as example, change, right click, edit the sketch. As you see, you can edit the sketch, you can edit the feature itself. Once you finish, just finish the sketch, it will be updated in the part and updated in assembly. No need to go back to the part, but once you finish updating the part, you have to go to return to the assembly. That's it. If you forgot the material for any part, you can go to that file. As example, I forgot material for the base. Double click on the base. See, I am in the base file now. Right click on the base plate, then I properties, go to physical. From physical, go to select. See, it is generic. You can use as example iron, ductile iron. Apply. Then return to the assembly. Everything will be updated. Don't forget to save the file inside the folder where you have the other parts and keep them all together. Thank you so much.